Hi everyone, I am Dr. A. Muriyasan from Department of Biomedical Engineering in KSR College of Engineering. In this video, we discuss the examples of Routh stability criteria. For example, take a open loop system G of S K given by G of S equal to K divided by S plus 4 plus 2 into S plus 3. So you have to find the characteristic equation. For finding the characteristic equation, you find the first closed loop response. So for that closed loop response, E of S divided by R of S equal to G of S divided by 1 plus G of S. So you have to find the closed loop response. The characteristic equation is the nothing but a denominator of the closed loop response. So finally we get the characteristic equation S power 4 plus 12 S2 plus 16 S square plus 190 S plus 200K. So here the highest power is the S4. So for to form the Routh array first S power 4, S power 3, S power 2 and S power 1 and finally S power 0. So you have to write the even coefficients in first row. So S power 4 coefficient of S power 4 is a 1. S power 2 coefficients will be the 69. The next S power 0, that will be the 200 plus K. So that will be the coefficient of S power 0. Then here next row will be the even powers coefficients. So S power 3 the coefficients will be 12. So S power 1 coefficient will be 198. So next you have to find the third row by using the formula, cross multiplication formula, 12 into 69 divided minus 1 into 198 divided by 12. So you get 52.5. Similarly, the next will be the next row. You have to connect 1 into 0 minus 200 plus K divided by 12. So they have get 200 plus K. So similarly, you have to find the next S1 value, then S0. Now you have to find the K value. In that, you have to, for stable system, the first column should be greater than 0. For that, so 60 S power 1 should be greater than 0. From that, you have to find the K value. So K is should be less than 600 and 625. We always know first column should be always positive. So 200 plus K is always K should be greater than 0, then less than 666.25. That is the value of K for stable system. So next example, so you have to characteristic equations directly given. You have to form the Routh array S power 5, S power 4, S power 3 and S power 1 and S power 0. First in this example we have first row have the odd number of powers. So 1, 2, 3. So second row having the even power coefficients 1, 2, 5. So next you have to form the row 1 into 2 minus 1 into 2 divided by 1. So we get 0 minus 2. So in that case, we cannot find the S power 2 row because anything divided by 0, it becomes infinity. So you have to change the 0 into the symbol of sigma. So change the 0 into sigma, then you have to proceed the problem as per the Routh stability formula. So you can find the next row consecutively. As we earlier said, for stable system, the first column will be the should be greater than 0. For that, 2 sigma plus 2 divided by sigma equal must be greater than 0. So that will you have to now substitute e to 0, then it will be infinity minus 2. Now look into the sign change. So here it will be the two sign changes, plus 2 minus, then minus 2 plus. So two sign changes in the first column. So there are two loops on the right side, then the system said to be unstable. So two sign changes, two roots are in S plane, so the system should be unstable. So in next example, so this is a third case of Routh stability. In that case, here not only the first element, the entire row will be 0. For that you have to take the auxiliary polynomial. So before the 0th row you take it as a auxiliary polynomial. So here s power 4, so I will write s power 4 plus 6x square plus 8. Now you have to find differentiation of auxiliary dA by ds. Then it will be the 4s square, sorry, 4s cube plus 12s s cube baro. So 4s cube, then you have to find, rewrite the table as a 4 12, then you have to find the remaining table. So now the first column, look into the first column, there will be no sign changes, then the system set to be stable. So these are the three different cases are in Routh stability criteria. Thank you.